Hi, so my name's Robert Taylor. I'm studying a combined degree in civil engineering and surveying. So the problem that we encountered is that often downstream of weirs and spillways in dams, there can be a lot of erosion that occurs. This involves the sediment being taken away from the downside of the surface face of the weir and then being deposited further downstream. And this is often caused by the change from supercritical to subcritical flow that occurs over the edge of the weir. And so we really want to try and reduce that erosion by implementing some baffle structures and a range of other structures that can control that flow, and where the hydraulic jump occurs, where it changes from super to subcritical flow, we're able to train the location of that position in the hydraulic jump. So the why in that is more or less around reducing erosion and trying to maintain the integrity of what is the existing creek or river structure so that there isn't environmental impacts further downstream. Part of the process that we looked at for this particular problem was first of all providing a set of parameters that we had that was standardised for the geometry of this particular scenario. So we created an experimental weir down here in the labs. And then we were able to go further and solve some numerical analysis and compare that numerical result to the experimental result. So what we did was we set up 3 different surfaces and a control surface, and then we would place these plates downstream of our experimental flume, which you can see behind me here, and that was able to then be run at a variety of different flow rates where we took measurements of the velocity before and after it hit those structures, and we were able to see whether the velocity did indeed change at all. And from that we were able to produce also a set of numerical results. My co-supervisor had some software available from Pacific ESI, from whom he also works, and we could simulate those results numerically and then compare those. The correlation of results is quite strong between the experimental and numerical, and also depending on which shape you're using, the velocity can be significantly reduced for certain flow rates and certain baffle types. So that's a really great outcome for this project, and something that hopefully in the future can have a real emphasis on discussion around these weirs and erosion reduction potential.